Please tell me you can hear me now. There is no sound issue. Can you hear me? Can you hear me now? Hi Radha, hi Ankit. Am I audible now? Yes, thank you Yuva. Thank you so much Amol. Finally, I think there was some glitch before, but so glad to know that the sound is working fine. We'll start in just a couple of minutes. We'll just wait our friends to join in. We have a lovely science session planned for you. So we'll just give it a moment and get started just in a bit. I'm going to introduce myself and tell you why we're here. All the information is coming to you in just in a bit. But yeah, we have some really cool magical science experiments lined up for you. Yes. Before we actually start, a big thank you to EuroKids International School for this great collaboration. For having us on board. We're Nutty Scientists, and this is going to be a very cool STEM initiative from their end. So don't forget to stay live with me for the next 40-45 minutes, where we're going to try and do some really cool hands-on science experiments. Hi everyone. I'm going to introduce myself, but there's one thing that you got to do. I'm from Nutty Scientist. I'm going to tell you my name, okay? But you cannot laugh, okay, everyone? You cannot laugh at my name. That's my scientific name. So my name is the marvelous Professor. Okay, don't laugh, okay, guys? My name is Professor Antenna. Professor Antenna. That's my name. You can send me emote icons, reactions. That's my name, Professor Antenna. There's anything that you want to ask, share, say, you can just call out my name, saying Professor Antenna. Okay, while we're on this session, I want you to think of a scientific name for yourself as well. You can be called Amit. Come on, don't laugh at my name, Amit. Okay, you can think of a scientific name for yourself. You can be called Professor. Think of a name and type it. You can be called Professor Light, Professor Energy, Professor Chocolate, Professor Cookie, Professor Ice Cream, whatever you want to be called, and I will call you through that name. Okay, thank you. Garima says that's a nice professor name. That's right, my name is Professor Antenna, and we're going to start in the next exactly 2 minutes, so that we have enough people who've logged in. I hope you have the materials that we had asked you to keep it with you. There were a few basic hands-on materials, regular household materials that we had asked you to keep with you, that you have with you. Even if you don't have, not to worry, you can watch the session and try it by yourself. I see there's a Professor Momo there. That's really funny. Professor Chocolate, that's sweet. Yes, think of some interesting name. Professor Momos is really funny. So Professor Atom, I'm going to read a few names. Think of something funny. So, Professor Chocolate. Why Professor Antenna? Because I'm always looking for new ideas, always searching for new ideas. Pulkit says Professor Chatterbox. That's nice. It's good to be Chatterbox. Professor Cupcake, Professor Nuclear. Great. We have a lot of professors here. So once again, thank you to EuroKids International Preschool for this lovely collaboration and STEM initiative. Make sure you're with us on this channel and stay logged into this channel. Professor Speed, Professor Windmill, Professor Champ. Okay, you know what? I think we should get started. Are you guys ready? Give me a thumbs up if you're ready. We're going to show you some really cool experiments. Professor iPhone, that's really fancy. Okay, Professor, there's Professor Alu and there's Professor Rasgulla. Okay, they had really funny names that I'm reading here. I think let's get started. So for the first experiment, we're going to do something really fun and really exciting. Make sure you have these ingredients with you too. If you don't, you can go and get it quickly as well. If not, don't worry. You can watch this entire video, try it later, and if not, the same video will be uploaded on EuroKids Instagram as well as YouTube channel and Facebook as well. So you will get to know all of this as well. And now there's Professor Google as well. Okay, there's Professor Google. That's lovely. So right now we're starting with the first experiment that we have here. And for that, I have this bottle. Okay, Professor Curious, that's nice. I have this bottle and I have this ping pong ball that has this weird eye on it. Okay, so what I'm going to do is something very simple. You can try it with me. I'm going to take this, okay, and I'm going to fill in some water till the brim, which means till the top of it. Okay, just watch. I'm going to try and fill it completely. I hope you're trying it with me, Professor Bottle. And I think that's enough. So we have filled this entire bottle, Professor Nitrogen. and I have this ball here. To make it more interesting, I'm going to add some food color. Let me add some food color so that it gives some nice color to the water. And you can see how this color is dancing through the water and going at the bottom. I'm going to give it a moment to mix so that it can mix completely with water. And now I have a question for you. Okay, I have a quick question for you. You have to answer and tell me what you think. I have this ping pong ball, or we call it the tennis ball, table tennis ball. I'm going to keep it here. And my question is, what will happen if I flip this bottle upside down? What will happen if I flip this bottle upside down? What do you think will happen? Come on, tell me. I'm going to give a minute to read all the answers and then I'm going to try out the experiment. It can be messy. The water can spill. If you haven't taken a shower, that's okay. But if you've taken a shower, then, you might get wet. Yes, it's turned red, Professor Nikhil, but bottle will turn upside down. What will happen? What will happen to the ball? Do you think the water will spill on the floor? What do you think will happen? Kishu is saying the ball will soak some of water. The color will stick to the ball. Some water can spill. Water never spill. Okay, I see quite a few responses there. That's interesting. Ball will fall and water will come out. That's what I think will happen too. Eyeballs will turn inside. Okay, that's a really interesting responses that I'm getting there. Let's find out what's going to happen. Sir, it is fall down. I'm sure it will fall down. Okay, let's find out. One. Okay, I'm feeling a little nervous here. Okay, give me some emote icons and reactions so that I feel a little more confident. And 1, and 2, and 3. Should I just leave it? Should I leave my finger from here? 1, 2. Is the water going to spill? And 3. What is happening here? Why is the water not spilling? Everyone who said water will spill, water will fall down, why is it not spilling? What's happening? Can I get it closer? Let me show it to you. What's happening here? Okay. Thank God that water did not spill, otherwise the entire space would have gotten wet with the first experiment itself. I kept the ball here, I filled the water till the brim, and all I did was turned it upside down, and 1, 2, and 3. Yay! Okay, I see something written there. The air took the space in. Well, we all know what is gravity, right? Yes, I see Vishal is saying I said ball will not fall, right? Aisha saying, oh my God, somebody saying the ball is stuck. Okay, so there is no glue, there is no Fevicol, there's nothing. I'll tell you why it happened. We live on Earth where there is gravity, which means everything that you throw up will come down, right? This is happening because of anti-gravity. The air pressure outside the bottle is different from the air pressure inside the bottle, and which is why change in this temperature is not letting this ball to fall down. The change in the atmosphere is not letting it turn down. High pressure, that's right, vacuum held it. Interesting responses. The air pressure is not letting this ball fall down. There's change in air pressure. The air pressure inside is different from the air pressure outside. And this difference, that's what I can read, atmospheric pressure. That's correct, Sanjeev. Yes, anti-gravity, that's correct. If you enjoyed this experiment, this was just the first experiment that we started off with, something that you can try it yourself with any kind of bottle. If you liked it, give me a thumbs up. Is the ball made of foam or plastic? It's a regular plastic ball that we play with table tennis. Yes, it's that simple ball. Now it's time for experiment. What if we put warm water? That shouldn't matter. Water is just water. Ball is light. Okay, there are a lot of responses coming in. I'm glad to see that. Thank you for all the hearts and all the likes there. That's very reassuring. Let's move on to something even more cooler. Tell me one thing. Do you guys like bubbles? Do you guys like bubbles? I love playing with bubbles. But what happens is each time I play with bubbles, it starts popping. The bubbles start popping, right? So I want to play with bubbles that do not end. Yes, can we try that? We want to play with bubbles that do not end. So for the next experiment, we're going to try and create something called as snake bubbles. Okay. What I want you to do for that is, I want you to have one bowl. Yes, like this. We have some soapy water. That's next. We have this Bisleri that we had. We've chopped it into half. We've cut it into half. The bottom half, we don't need it. But this half, which has a mouth, is like this. Okay, you can watch, even if you don't have it right now, not to worry. This video will be uploaded everywhere, so you can watch it later on and try it. Yes, somebody's asking, is color also important for this ball? No, color is not important. Let me tell you, I added this food color before, just so that, it gives a little more feel to it. Because water is transparent, which is why I added a little color, so it's more visible to our eyes. That's all. I love bubble. Great. I'm a EuroKid baby. That's lovely. So let's watch this experiment. You will have a lot of fun with this experiment. So we have this bottle which is cut from the second half. The bottom is cut. So ensure you get your parents or you have some adult cutting it for you. So we have this, and what else do we need? We have a sock. Yes, not a smelly sock, not a used sock, a fresh sock that I got for this experiment. Yes, this is the socks that I have. Now I'm going to show you what's going to happen first. So I'm going to take this soapy water, okay, inside this bowl like this. Very simple, okay. I'm glad to see everyone likes bubbles. So I have this soapy water which is inside this bowl. What you can do is, you can also take some dishwashing soap, pour it into it. How much? A couple of spoons, 3 to 4 spoons. Add some water and just dilute it. Because this is concentrated, we're going to add some water and dilute it. Okay. And after you've diluted the soap, you can mix it with a spoon. You can mix it with a spoon and you will have something like this, which is a soapy water. Now the next step is something very simple and very interesting. I'm going to get this sock. I'm going to get this bottle to wear the sock. This half, which has a mouth, I'm going to get it to wear the sock. So basically the sock was like this. What soap is added for making this? Regular dishwashing soap, hand soap, yes, any liquid soap. Any liquid soap will work. Okay, Nikita, any soap will work. So I'm going to make it wear this sock like this, so that you can see the mouth of it is empty like this, is visible. Vim or Scotch Brite, both will work, my friend, both will work. And I have this. Now the next step is very simple. I'm going to dip it inside this. Okay, I'm going to dip it inside this. I'm going to dip it like this. I'm going to mix it with the soapy water. And now the next step is something very simple. What fabric is a sock? Is just a regular sock. It doesn't require to be of a specific fabric. Okay. Shalu says, I know this experiment. You can help us with this one. Nylon sock will work too. And now is the time to see whether this experiment works. It's science, right? Sometimes it works, sometimes it doesn't work. Let's see if it works this time. All I'm going to do right now is I have dipped this bottle, any kind of soap. Yes, any kind of liquid soap will work for this. I have dipped this bottle, which has a sock on it, inside the water, and it's become wet. And now I'm going to blow air into it. All I'm going to do is blow air into it, right? I'm just going to blow air into it. 1, 2, let's watch. And okay, there's a spell that we need to say. There's a spell that we need to say. Only then it works. It says, if you are in trouble, you can type it with me. If you are in trouble, make some bubbles. Let's see. 1, 2, 3. Oh, the soap. Let me try it once again. Okay. Yes, I'm waiting too. Okay, there's a bit of coming up. Let me try it with adding more soap to it. Let me add more soap to it. Just give me a second. I'm going to do this right away in front of you. I'm going to add some concentrated soap. Yeah, right here. I'm going to add some water. If you are in trouble, make some bubble. That's right. And I'm going to mix it with a spoon quickly. Mix it, mix it, mix it, mix it, mix it. Let's mix it. Yes, until you have created bubbles. And there's a little water which I'm just going to quickly wipe it. Yes, there's a little water here. Make sure your electrical items are not around, like mine. And let's try this one more time. Okay. And okay, Let me try it. So it's creating a little bit of bubble. It's supposed to create a lot of bubbles. Let me know if it's happening with you. If it is working for you, give me a thumbs up. Yes. If it is happening with you, give me a thumbs up. If you've tried it, it's going to create a lot of bubbles. Done from my side. Swati, did it work for you? You can actually upload your experiments and tag us. You can tag Nutty Scientists Mumbai, and you can also tag EuroKids. Yes, and show us how did your experiment work. Well, yes, finally. I think patience is the key, right? It worked. Here you go. I was feeling this experiment is not working. Why is it not working? But science never fails. Yes, right, you see? So this lot of don't blow in, just blow out. As you can see, there's a lot of bubbles here. Yes, did it work for you? If you have smaller kids, you can do it for them. But first teach them how do you blow air into it and then work. Okay, let's try it one more time. And then I'm going to move on to the next experiment. Give me a quick thumbs up if it worked for you, or you're going to try it later on. And ensure you tag us as well so that we can see. There's another interesting thing that you can do. You can also add some food color on top, so that the bubbles that will come out will be colorful. Let's try if it works. Yes. Yes, we can see bubbles here. Something really cool, something very simple, but works really well. All right, I'm just going to quickly wipe my hands with all the bubbles here. Thank you for all the thumbs up. I think that was really cool with bubbles. And now, let's do something even more cooler. The next experiment that I want you to keep your materials ready for. Yes, Divya, please try it later on and tell me. Yes, somebody's saying you can cut your socks short. Yes, I think that would be better. The socks that I have always will be longer. Ideally, if your sock, which is just enough, an anklet sock, which just fits in, will be better. Thank you. Yes, the idea is to always learn something new. As this year ends, let's learn different things. The next experiment is something even more cooler, which is called the lava lamp. I'm going to tell you what all do we need. We need an empty bottle. Yes, I'm going to keep it in front of you. Empty bottle like this. We're going to need some oil. Yes, the oil is here. Yes, good suggestions. Mahiba is suggesting we can tie a rubber band if it's loose. That's correct. All the suggestions are welcome, because I think in science there is no right or wrong. It's only about giving it a try. I have some food color. I have some packet of Eno. Yes. And I have a torchlight, which is working. Okay. So the first step is very simple. If you have the materials with you, great. If not, watch it and try it later on. And you can also watch this video later on EuroKids International Instagram and YouTube channel and Facebook. So first step is something very simple. I'm going to add some oil. Okay. This is regular oil. Yes, I'm just going to open the oil's lid and add it. Yes. So let's add some regular. This is a regular oil that we use at home. Not very particular. I'm going to add only 1/3 of it. I think this is enough. Yes, 1/3 of it. This is a regular oil that I've got from my kitchen. Okay, no special oil. So this is an oil that I have, which I've filled 1/3 approximately. Now the next step is I'm going to add some water. Okay, watch. And I'm going to try and add a lot of water so that it completely go till the brim. That's it. Cooking oil or hair oil. Cooking oil should work. Yes, cooking oil should work. Yes, not too much. We have to be careful with the resources we use. So just 1/3 of oil. Cooking oil is going to be fine. Yes, everyone, cooking oil should work for you. So tell me one thing. I have a question. The first thing that I added was oil. The second thing that I added right now is water. But the oil seems to be on top and the water seems to be at the bottom. Why is that? A quick question. The first thing that I added into this bottle was oil. The second thing that I added into this bottle was water. but the water seems to be at the bottom and the oil seems to be at the top. Why is that? I'm going to wait for a moment. Oil is lighter, Sharon, that's correct. Buoyancy, that's correct, Naveen. That's the concept. Yes, cooking oil should work. Density, that's correct, everyone. Thank you for participating. Density is correct, which means if it's heavier, which means it's denser, which means it's going to be at the bottom. So water is denser than oil, right? I'm going to repeat that. Water is denser than oil, which is why oil is at the top and water is at the bottom. Okay, the next step, something very simple. I'm going to add, what's the ratio between oil and water? Like I said, the oil was 1/3 of your bottle, 1/3 of your bottle, and the remaining whole bottle is filled with water. Okay, density is absolutely correct, which is why if you notice, if we are in a swimming pool and if we become a ball like this, we will sink, right? But if we stretch ourselves into a swimming pool, we will not sink, we will float. That's again because of density. And right now, I'm going to take green color of Christmas, and add a couple of drops into it. I have taken food color. Yes, I've taken a couple of drops. I think 2-3 drops should be enough. Now, as you can see, that the food color that I've added right now is still at the top. Yes, it's still at the bottom. It hasn't reached the water. Correct? It is still in the oil. What I'm going to do next is something again very simple. Let me show you step by step. First, I took the bottle, then I added oil 1/3, then I added some water till the brim, and then I've added a couple of drops of food color. Now, what I'm going to do is, I'm going to keep a torchlight ready, which is here, under it like this, and I'm going to add some Eno. Yes, I'm going to add some Eno. So I'm going to show you what's going to happen. Let me just open it and make sure you watch this. It's even more interesting if you do this experiment in complete darkness, because that's the fun. We're going to try and create some lava lamp like that. So I'm going to keep this here, keep this like this. Okay, and you can watch the water drops. The food color is still at the top, at the surface, and now I'm going to add few. Yes, that's right. And 1, 2, and watch. I'm not going to say anything. I'm just going to let you watch. Let me get it closer. What's happening? Show me your reactions. So I know there's something. I see a few hearts there. Is it like a lava lamp? Do you think we're creating some lava? I see a reaction called whoa, woo. That's interesting, right? All we did was water, oil, a torchlight. You can use a phone light, and Eno. And how much Eno? Just 1 spoon. I still have enough to do this experiment at least 2-3 more times. And it's even more interesting if the lights are shut. Right now I'm not going to shut off the lights, but you can try this and your children will absolutely love it. It's called the lava lamp. Now, why is this happening? Let me give you a quick explanation. Because of density, change in density. Also, the food color that we used is made up of water, right? It has water droplets, but it did not mix with water until we added Eno. As soon as we added Eno, yes, the change in the gas made it. I'm going to read what it is saying. The light is producing heat. That's right. Yes, the color does not mix in oil. That's correct. The color, that's what I was just saying. The color did not mix in oil, but as soon as we added Eno, and what happened is it started going up and down, and it mixed with water, getting the food color to mix with water and creating an effect which is called as lava. I'm glad the kids are enjoying it. I'm equally enjoying it while doing it with you. Yes, lovely, right? Let me see if I add some more, what will happen. Yes, I've added some more right now. Science is all about trying it out. You can see now it's still, the effect is there, but it's a little slow. All right. Great. Yes, you should try this potion. Just one thing, because there are particles here, you can see there are bubbles here. So we will not close this bottle right away. We will wait for all the bubbles to disappear and only then close this bottle. So I'm going to keep this bottle right here and do the next experiment. Give me a thumbs up if you like the experiment. Thank you so much for writing such sweet things. I'm glad that the children and the parents are liking the experiments, and I want you to try it later on. And you can tag us. You can tag Nutty Scientists Mumbai here. You can tag EuroKids International and show us how your kids are doing the experiments. Great, I'm going to keep this here. So we are done with 3 experiments and there are a few more to go. We'll try and do as many experiments as possible, but if not, you can stay connected on this Instagram channel and we will be uploading more Instagram reels that will have such STEM content. Without torch, what will happen? That's a good question. Without torch, the effect is still the same. Yes, without torch, the effect is still the same. What happens is with an external force light, it becomes more interesting. That's why. And I'm using this torch light, not a phone, because I don't want anything to be spilled on the phone. So if you have a torch light, just use a torch light. Great. Let's go on to the next experiment. All right, now for the next experiment, we have some really interesting things. But for the first one, I'm going to show you this one. It's called Rainbow Geyser. Yes, it's called Rainbow Geyser. What I'm going to do is, I have some vinegar here with me. Yes, let me just show you. I have some vinegar. And you can get the materials too, some very simple materials. We have vinegar, we have baking soda, and we have a spoon here, and we have some food color. That's all we need. Okay, so I'm going to add some vinegar, about half a cup. Yep, about half a cup is more, or even 1 cup actually. What happens if you don't have food color? What can we use? You can use paints, or water paints. I think that should also work. Thank you, Professor. I'm going to add some vinegar in all 3 or 4 cups. Yes, we have how many food color? We have 1 here, 2 there, 3. Let's try it with 3. It'll be interesting. Okay, so I've added vinegar in these 3 cups. Okay, now let me show you what happens next. I'm going to make it a nice triangle here. So we have vinegar in these 3 cups, which have a very peculiar smell. Now, the next thing is I'm going to add some food color. Okay, let's add some food color, just a couple of drops. 1, 2, 3, 4. Yeah, that's enough. So there's 1 color there. Let's add red. Christmassy feels. Green we've added. Adding red. Okay, and there's 1 more color that I'm going to add, which is blue. Let's add blue. Is there any alternative to vinegar? Not really, because this experiment is specifically done with vinegar and baking soda. But vinegar is something which is easily available, so you can always try it later on. Okay. Okay, so what color do we have? We have orange, we have red, and we have green. Okay, and I have some vinegar which I've poured inside this. Now I'm going to take a spoon and just quickly mix it. Mix it. We can use the same spoon, that's all right. You can use a stirrer if you have. And now is the final step. I have some baking soda here and I have this spoon. What I'm going to do is, I already have a spoon inside this. I'm going to take 1 spoon and pour it inside this and show you what's going to happen. Yes, is it clear for you? You can see it. 1, 2, and 3. Let's try and see what's going to happen. 1, 2, and 3. What's happening here? Do we have a small kind of a lava here, or a rainbow geyser as we call it, coming out of it? It's pretty interesting. Let me add some more. What is oozing out of it? Red one is also, this is the red one actually, this is the orange one, but you can see they all have fizzed. It's coming out slowly. Even the green one looks like an ice cream scoop, right? Yes. What is happening here is something very simple. There is a chemical reaction happening. What happens is, you can teach this to your children. When A and B come together, they form a chemical reaction. Yes, A and B coming together and forming a chemical reaction. So when your children are actually clapping like this, they will remember the term called chemical reaction that will help them in the retention. They will remember the terms and the concepts like this. Always teach them with some gesture or some sound. So A and B coming together and forming a chemical reaction. How is this a chemical reaction? We had liquid, vinegar is liquid, and baking soda is solid. So we had liquid, we had solid, and they came together and they formed a chemical reaction because they released something called as gas. Which is the gas? The gas is called CO2. Yeah, CO2. Always teach your children with a lot of visuals. CO2, they'll always remember. So what we just created was a chemical reaction. Very interesting, right? I'm going to keep this away. Time for the fifth experiment. I'm going to try and do as many experiments possible as today. I've got some really interesting things planned. For the next experiment, what I want you to do is, without wasting any moment, I've got some milk. Yes, that's right. Results CO2 releasing in the reaction. That's correct. I've got some milk. Yes. I've got some Qtips, or we also call it as earbuds. And I have some food color. Again, food color plays an important part today. And I've got this tray. Yes, I've got this tray, which I'm going to keep it here. Let me keep the phone a little at the back so the visibility is better. Yes, I've got this tray, or you can use a steel plate or a glass plate, whatever you want to use. Okay. Okay. I think that's reading my kid is imitating you. I'm glad. All the young professors and all the junior scientists out there, you should try all the experiments. Okay, I'm going to pour in some milk without wasting more time. How much milk is a good question. So milk that touches the surface of the borders. Yes, not added too much milk, just as much as it can touch the borders. Yes, and now that's your first. Recording will be available, my friend. It will be on EuroKids International YouTube channel and on Instagram and on Facebook. So you can watch all the experiments, try it, and share some new ideas with us so that, learning never stops. So we've added some milk here. Now, the next step is we're going to add some food color. Okay, just one drop each, or I think two drops each should be enough. Let me show it to you, taking it a little more back. Let me take this a little more back. Is it raw milk? Yes, it is. It's not boiled, it is raw milk. A couple of drops here. So we've added yellow, we've added red. Let me see what other colors do I have. I'm going to add some green. Okay. I have one more color here. Let me see which one is this. Okay. Now is the next step. I'm going to take a Q-tip. Okay. This is not for me to clean my ears. No. This is for the experiment. So I have this dishwashing soap here. I'm just going to dip it inside this, right? I'm just going to dip it so that the tip of it is mixed with the dishwashing soap. Okay. Now is what I'm going to show you what's going to happen. So we have different drops of milk, as you can see here. Yes, I'm going to show you right now. I'm going to hold my hand here. And what's going to happen is I'm going to just touch it on the surface. How many colors? You can use how many ever colors you want. I have used 4 colors right now. I have a Q-tip that I have dipped in milk. And all I'm going to do right now is just touch the surface. Okay, I'm just going to touch the surface and let's see what's going to happen. And I want to see your reaction in this one. 1, 2, and 3. What just happened? Each time I touch the surface of the milk onto the color, what is happening? Is it creating a nice graffiti here? Let me touch the yellow. Colors will go far away. Are they running away? What's happening? Let's try and create some nice, interesting graffiti here. Yes, it's creating a very nice visual, as you can see. It's creating something on its own. All I'm doing is just touching the surface. That's all. And I'm going to leave it here. What just happened? It's still happening. You can see the milk is still trying to run away from each other. What is happening here? And why? Can somebody tell me why? Surface tension? Yes. What is actually happening is that the molecules of the soap, yes, there are molecules on the soap. So molecules of the soap are attracted to the fat in the milk. As we all know, there is fat in the milk, yes. So the molecules of the soap are attracted to the fat of the milk. But as soon as you touch the surface, it starts throwing the water molecules away. It starts throwing the water molecules away, or the soap molecules as we call it, and it's pushing it on the corners. So all the color that was there in the center is going at different ends. It's going at different borders and it's coming almost to the surface, right? It's not a chemical reaction as such, but what we read there was something closer, surface tension. We can also call it diffusion, because what is exactly happening is it's running away. The water molecules are running away from the milk molecules. Let me just read. Molecules of the soap are attracted to the fat in the milk. Yes, that's what I just said. And as soon as you dip the soap, it starts pushing the color away. That's what is happening, and because it pushes away, we get this nice lovely formation in the center. Do you like this? Of course we cannot drink this, but it's for experiment, and this is what it looks like. That's correct. I'm going to keep this away, and time for something even more fun. Before I show you a couple of demos as well, we have about 5 minutes more. I'm so glad that your son is enjoying it. I'm enjoying it here as well. We have one quick experiment here. I have this, something very simple. I have a glass, yes, and I have some thread, and I have some tape, and I have one scissor. Be very careful when you use the scissor. Make sure you have an adult around you. That's it. I have just these 3-4 things. Now I have a question for you. Okay, you have to answer this for me. I'm going to just try and do something like this. I'm just going to try and pull the thread down. Tell me if you can hear any sound. Can you hear any sound? Yes, no, maybe. You can type so that I know you're listening or you're watching. Do you hear any sound? Do you hear any sound coming in from the thread? Do you hear any sound coming in from the thread? You do? But that's very, very minute, right? It's not very loud. Yes, you can? Okay. If you could hear it then, now I'm going to take a cup that has a little water. I'm going to dip my fingers in it. Yes? And let me just wipe my hands. Okay. Now, let me try this again. Okay, let me try it again. Okay, just give me a second. Let me try it once again. It's supposed to create a very funny sound. Okay, let me just wipe my hands very properly and use some water which is out here. And let me try it here. I have this bowl here. I'm going to keep it here. And let's try it again. Did you hear that? Did you hear that? What kind of sound is that? Is it like a trumpet? Is it like a cat? Can you tell me what does this sound like? Is it like a cat or a dog or a puppy? When my hands were not wet, the sound was not very clear. It's actually called, this device is actually called Qtips. Yes, it's a Brazilian instrument called Qtips, and it's creating this funny sound, right? Baby crying is interesting. What else? Come on, at least give me 5 responses. Tell me 5 responses of how does this sound like. It's funny. Puppy. Okay. Meow. What else? Trumpet. Yes. Okay. Okay, this is very addictive. I'm going to continue playing with it, but I should stop. So I'm just going to do it a couple of times. And yes, it is like a baby crying or a sound of a cat. It's very simple. Now let me show you, or a door closing is very interesting as well. The door closing. I'm going to show you how this exactly works. Or a baby laughing. all I did is I have this paper cup. Yes, we have this paper cup. I'm going to try and create very simple experiment that you can try it with your children. I have this like a toothpick. I'm going to try and create a hole here. Yes, just watch. Yes, I'm going to try and create a hole. Okay, I've just created a small hole here. I have a thread here. Okay, let me just show you. I have this thread here. Okay, and what I'm going to try and do is I'm going to get this thread to pass through this. Okay, I'm going to get that thread to pass through this. Okay, I created a hole on top of it and I'm getting some thread to pass from this. That's all I've done, and it's like this, and I'm gonna stick this with a tape. So let's try and do that together. Yes, it's right here. Tell me if you're trying it with me or you're going to try it later on. Okay, I have a thread here as well. Yes, Anjana, that's nice to know. Alright, I'm going to take this and I'm just going to stick it on the bottom like this so that the thread doesn't come off. Yes, so that the thread doesn't come off. And it's ready. Let's try it again. Let's try and dip our fingers through water and tell me if it works for you. What we're creating is something called as Qtips. It's a different sound from this. Alright, yes, you can try it later on. So what we just created is Qtips, and this was the end of the 6th experiment. Does it have to be a paper glass or can it be a plastic? I think paper cup works better, but why don't you try it with plastic as well and tell me if it works. You can always tag us on Nutty Scientists Mumbai and on EuroKids International. Now before we go, I have 2 quick things to show you as a part of a demo. We have about 2-3 minutes left. I have this problem here. Science always has problems, so does it have solutions. I have these 2 books here, I have these 2 books, but I've been trying to pull it apart, but it's not happening. Can you tell me why? I'm really trying to use all my muscle power, but the books are not coming apart. Why is it happening? Why are the books not coming apart? Yes, you can see the books. I'm trying to pull it really hard, but the books are not coming apart. Yes, they are stuck, but why? Who can tell me why? Come on, tell me quickly. Why are the books? No, there's no gum on it. Come on. There is no glue stuck. It's stuck, but why? Why is it stuck? Mr. Dr. Saurabh is saying friction. It is stuck with each other. Yes, it is. But why? Why is it stuck? Is it a book cover? It's a book. It's a hardbound book. Yes. But why is it stuck? There are pages inside. Let me show it to you. This is a better view. So it's not just the cover. There are pages here. Why is it stuck? The pages are interlocked or intertwined, as we may call it. Vandana, that's correct. The papers are overlapping, and as the doctor said earlier, it is creating friction. Yes, what is happening? It's creating friction, which means if you rub your hands like this and touch it on your cheeks, you will feel warm. That's because 2 forces are going against each other, right? 2 forces are going against each other. That is the same thing, the same concept is applied here, and it's creating friction. Yep, you can see this. All right, that was the end of today's session. We did how many experiments? Let's count together. We did anti-gravity, we did lava lamp, we did diffusion with the milk, we did rainbow geyser, we did Qtips. What else did we do? Lava lamp as well. 6 experiments, that's right, 2 forces are going against each other. I hope you really enjoyed the session. This was really fun collaborating with EuroKids International, who gave us a chance to Nutty Scientists Mumbai to come live and show you guys some really interesting experiments. So yeah, that is it from today. Thank you very much for joining in. You can watch the video on EuroKids International Instagram, Facebook, and on YouTube channel. Stay tuned because EuroKids is going to bring a lot more STEM related content, science related content on their channel, which you can watch, learn, and continue to learn. So that's it from today. Let's say this together, as I always say before ending a session. FlipFlop Fluff. Yes, let's say it together. FlipFlop Fluff. FlipFlop Fluff. That's the end of the stuff. Thank you so much. I'm just going to wait for a moment to see if you have any thoughts, any feedback. How did you like the session? Somebody saying thank you, Professor Antina. All of you are most welcome. I'm so glad you could take some time out for your children and for yourself and try out the experiments with me. Looking forward to more sessions. Even we are looking forward. But stay tuned. As I said, EuroKids International is constantly going to bring you a lot of such experiments, a lot of such STEM related content to you. Most welcome, all of you. All right then. Most welcome, Sharon. I'm so glad the children have had fun today. I've equally enjoyed trying out these experiments. Like I said, science is all about trying. Sometimes you fail, but sometimes it works. All right, everyone. Thank you very much. FlipFlop Fluff. That's the end of the stuff. Signing off from Nutty Scientists, Mumbai. Stay tuned. See you guys very soon. Bye-bye. Ta-da.